Welcome to Justin Tutorials. Today we are going to talk about Krebs cycle. The Krebs cycle is an amphibolic pathway. It is also known as the tricarboxylic acid cycle. So in this video we are going to look at the different reactions that take place in this Krebs cycle, the intermediates that are involved, and the enzymes that are involved. Before I will move to the general reaction, I want to give you a way that you can remember the intermediates in Krebs cycle. This citrate is the first intermediate. is the isocitrate. Krebs is the alpha ketoglutarate. The starting is the succinyl-CoA. The substance is the succinate. The for is for fumarate. The making is for malate and oxaloacetate. This is our acetyl-CoA. You know that all biomolecules will be converted to acetyl-CoA before energy can be generated. Your carbohydrates, your proteins, your lipids will be converted to this acetyl-CoA before it can generate energy. This is a disulfur bond, the hydroxyl group. It helps in the stability of the coenzyme A. When it fuses with your acetyl-CoA by the enzyme citrate synthase, you are going to get, this is your oxaloacetate. You are going to get citrates or citrates. Citrates will be converted to isocitrate by an enzyme known as aconitase with the release of water. So isocitrate will be converted to alpha ketoglutarate, enzyme known as isocitrate dehydrogenase. Whenever you see a dehydrogenase enzyme, that should let you know that a reducing equivalent, which is NADH or NAD, they are high energy compound. NAD positive will come and acquire hydride. So it comes out as NADH, forming alpha ketoglutarate. And that enzyme will also release out a carbon in form of CO2. This is the structure of your alpha ketoglutarate. Alpha ketoglutarate will be converted to succinyl-CoA. And the enzyme that will catalyze that is alpha ketoglutarate dehydrogenase. The enzyme that will convert this is alpha ketoglutarate. Alpha ketoglutarate dehydrogenase. Also, as you know, I said earlier that NAD positive will come and acquire a hydride and become NADH. Also, this enzyme will add a coenzyme, a disulfide bond and a coenzyme to the reaction, forming succinyl-CoA. Now, succinyl-CoA will be converted to succinates. The enzyme that will catalyze that process is succinyl-CoA synthetase. Succinate will be converted to fumarate. Succinyl will be converted to fumarate. And the enzyme that will catalyze that process is succinate dehydrogenase complex. FAD will come into that reaction and come out as FADH2. This high energy compound donates this hydride to the second complex in your electron transport chain. In the course of generating energy, this FADH2 is being donated to the electron transport chain, complex 2 in particular. So fumarate will be converted to malate. The enzyme that will catalyze that process is fumarase. And malate will be converted back to oxaloacetate. And the enzyme that will catalyze that process is malate dehydrogenase.